We're going to cover lesson 80, which has more trig identities. So I did attach a handout that has all the trig identities in lesson 76. I would advise you to print it and have that like in your book or in your notebook or wherever, and you can always reference it. It also has the unit circles on it. In your textbook, page 485 also lists a bunch of identities. We're going to cover 3 of them today and use proofs that handle them. So there are 3 new ones I'm going to cover today. The first is that the sine squared of theta plus the cosine squared of theta equals 1. The next one I'm going to cover is 1 plus the cotangent squared of theta equals the cosecant squared of theta. And let me zoom out just a little bit. And then the third is the tangent squared of theta plus 1 equals the secant squared of theta. Now, each of these has 3 forms it can be written in, right? Because you can move each of these pieces around. So I want you to know that these come in 3 forms, but you need to just memorize the first one. So if you can memorize the first one, you should be able to manipulate it and move it around. So 2 other forms of the first one would be that cosine squared of theta equals 1 minus the sine squared of theta. And the opposite could be said of the sine squared of theta would be 1 minus the cosine squared of theta. You're just moving one of these to the other side. So if you memorize the first one, you should be able to manipulate it into the other 2. So for the middle one, I can rewrite this to be 1 equals cosecant squared of theta minus cotangent squared of theta. I could also rewrite this to be cotangent squared of theta equals cosecant squared of theta minus 1. This one can be written right, tan squared of theta equals secant squared theta minus 1, or 1 equals the secant squared of theta minus tangent. So each of these can be written 3 different ways. Now we're going to prove these 3 that I've highlighted using this triangle. So this is a Pythagorean triple. So if I say this is 3, 4, and 5, and this is theta. So we're going to prove the 3 above that I highlighted in yellow. Okay, we're going to prove the 3 above that are highlighted in yellow. So I'm going to prove part A. So if I said the sine squared of theta plus the cosine squared of theta equals 1. So here's theta. The sine of theta would be opposite over hypotenuse squared, and here I'll label the sides. So I have opposite, adjacent, hypotenuse, plus the cosine squared of theta. Cosine would be 4 adjacent over hypotenuse squared, and that would give me 9/25 plus 16/25, which would equal 25 over 25, which equals 1. So I just proved this, that the sine of theta squared plus the cosine squared of theta equals 1. So now I'm going to prove part B, that 1 plus the cotangent squared of theta will equal cosecant squared of theta. So, let's fill this in. So tangent of theta, because I'm writing that because it's reciprocal of cotangent. Tangent of theta would be opposite over adjacent, so that would be 3/4. So I'm going to bring down 1 plus the cotangent would be the reciprocal of that, and it's squared. Cosecant is the opposite, reciprocal of sine, and the sine of theta is 3 over 5, so the reciprocal would be 5 over 3 squared. Okay, so I'm going to simplify this and prove this one. So 1 plus 16 ninths equals 25 ninths. And then I'd have to convert the 1 to a common denominator. So 9 over 9 plus 16 over 9 equals 25 over 9. And that is true. You get 25 over 9 equals 25 over 9. So I did prove that they are equal. So let's prove that final one, that the tangent squared of theta plus 1 equals the secant squared of theta. So tangent squared of theta plus 1 equals the secant squared of theta. So we wrote above what tangent of theta is. So this is 3/4 squared plus 1. Secant is the reciprocal of cosine, and cosine would be 4 over 5. So secant squared would be 5 over 4 squared. So this gives me 9 over 16 plus, I got to make this a common denominator, so this would be 16 over 16, right? Equals 25 over 16. And this side equals 25 over 16, and this side equals 24 over 16. So I have just proved these identities using a triangle with real dimensions, that these three identities work. So we are now going to do some using these identities to prove statements true, okay? So example number 1, so we're going to use identities to prove the following. Number 1, show that the secant squared of x, it can be x or theta, minus the tangent squared of x, all over 1 plus the cotangent squared of x, that all of this equals the sine squared of x. So if you have your proofs out, I'm going to try to use the values of what we just proved to prove that this statement is true. So the first thing I'm going to do is prove the left-hand side. So I wrote it down, and I'm trying to find where I wrote it down. All right, so I'm going to look for the proof that involves the secant and tangent, which would be this last one. Okay, so I know that secant squared of x minus the tangent squared of x, I know that this top part, based on this proof that we wrote earlier, we have it right here, the secant squared of theta minus the tangent squared of theta equals 1. So I can replace this top part with 1. This is, and maybe I'll write a note, this is proof C from the prior page. And this bottom one, look, 1 plus the cotangent squared of x equals cosecant squared. So the bottom part is proof B from the prior page, and it just equals the cosecant squared of x. And this is the reciprocal of sine squared x. That was one of the first ones I gave you, that the cosecant of theta equals 1 over the sine of theta, and here it is. So this is a proof that should be on your printout. That printout looks like this. And so that is right here. The cosecant of anything is equal to 1 over the sine of that, and the same is true in the reverse. So we already proved this. So next one, show that 1 over the tangent of A plus the tangent of A equals the secant of A times the cosecant of A. All right, so there we go. So let me make sure I wrote this down right. Yes. All right, so I'm going to replace each of these. I know that this has the same value as the cosine of A over the tangent of A. And I'll know that because, where did I write it down? I know that because tangent equals opposite. Well, it's not even written on here. Where is it? It should be on here. On this sheet, the tangent of theta equals the sine of theta over the cosine of theta. And that would mean that the cotangent of theta equals the reciprocal. And so that's where I'm getting this. I know that so if this helps, let me do this in smaller steps. I know that this equals the cotangent of A. Okay, maybe that would, and then plus, I know this is the same as the sine of A over the cosine of A. And then I'm going to rewrite this one. The cotangent is the same as the cosine of A over the sine of A. And I'm just going to rewrite this one. And then I'm going to add, so that may be doing that in steps. You can see this equals the cotangent, which equals this. Now, in order to add these, I have to find a common denominator, right? I'm adding two fractions, so I'm going to multiply this one by the cosine of A, and I'm going to multiply this one by the sine of A. So I'm trying to create common denominators. And that gives me the cosine squared of A plus the sine squared of A over your common denominator, which is cosine A times the sine of A. Now, from there, I am going to, this equals the top, sorry, I just froze. So in our proofs, I know that the sine of theta plus the cosine of theta equals 1. This top part right here is proof A from the prior page, and it just equals 1 over the cosine of A, sine of A. Now I can separate that to then be 1 over the cosine of A times 1 over the sine of A. And 1 over the cosine of A is the secant, because they're reciprocal functions, and 1 over, that's right here, cosecant is 1 over sine, secant is 1 over cosine. So this is the secant of A times the cosecant of A. So we just proved it. I know it's kind of crazy. I know it might be hard to see these at first, but give it time and you'll start to see them. Next one, we're going to show that 1 over 1 plus the cosine of A plus 1 over 1 minus the cosine of A equals 2 cosecant squared of A. All right, so this one again we are adding, and in order to add I have to create a common denominator. In this case I know my LCD is 1 minus the cosine squared of A, because you would multiply these. So I'm going to have to multiply this fraction times 1 plus, times 1 minus and I'm going to have to multiply this fraction by 1 plus the cosine of A. So I get 1 minus the cosine of A plus 1 plus the cosine of A. over 1 minus the cosine squared of a, because that's my least common denominator. So in the top, I'm going to combine like terms, and I have 1 minus the cosines cancel, and I have 2 over 1 minus the cosine squared of a. Now this guy right here is from proof part, that is from proof A. If I subtract, then this just equals the sign. So I now have 2 over sine squared of a, which equals 2 times 1 over sine squared a, which equals 2 times the cosecant squared of a. I know that's a lot. Next one. The cosine of a over 1 plus the sine of a plus 1 plus the sine of a over the cosine of a equals 2 times the secant of a. I'm kind of running out of room. This might have been a little... All right. My LCD here between these denominators would be cosine of a times 1 plus the sine of a. I would just simply multiply. So I would have to multiply the first times the cosine of a, and I'd have to multiply this next one by 1 plus the sine of a. So I'm just simplifying the left. So that would give me cosine squared of a plus, I would have to multiply, I would have to distribute these, and that would give me 1 plus the sine squared of a plus 2 sine of a. If I distribute that all out over my least common denominator, cosine a, 1 plus the sine of a. Now, based on our proof, I know that this plus this equals 1. So I have 1, this is 1. So 1 plus 1, I now have 2 plus 2 sine a over cosine a and 1 plus sine a. Now I can factor the top. They both have a 2 in common. So I'm left with 2 times 1 plus sine of a. Hopefully you can kind of see what's about to cancel. So these are gone. And I'm left with 2 times 1 over the cosine of a. And 1 over the cosine of a is the same as secant of a. So we just proved it. Now I'm going to stop there. I think that's enough examples for this section. Homework for 80, you're going to skip numbers 2, 4, 5, 10 through 12, and 22. Thank you.